Welcome to the Scaling Tech Podcast, the podcast for growing engineering teams. As always, this episode is brought to you by AgilityFeet.com, providers of technical staffing and software development services in Latin America for clients globally. Hi, I'm Aaron Syme, host of the Scaling Tech Podcast, and for today's live episode, I'm joined by Mihir Vora, a senior distinguished engineer at Capital One. Mihir has a passion for empowering teams and driving innovation. A firm believer in influencing without authority, Mihir has successfully balanced technical contributions with strategic leadership. With over 15 years of experience in cloud engineering, DevOps, full stack deployment, he's been instrumental in transforming banking through technology. His expertise in optimizing developer experience and accelerating software delivery has led to significant improvements in productivity and efficiency. And today we'll be discussing the evolution of DevOps, automation, scale, and the AI frontier. Mihir, thank you for joining me today.
Hey, thank you, Aaron, for inviting. And I've been looking forward to this for a long time. So thank you for doing the podcast. Like you've got a lot of insights from the industry in there, like a lot of gems in there. So I'm just honored to be here today.
Well, thank you for your very kind words. No, the pleasure is all mine. It's wonderful to have you here with me today. And I know you've got a lot of great experience and expertise. And so it's wonderful to have the chance to share this with our audience. And speaking of our audience, for those of you with us live, you can ask a question in the comments anytime in LinkedIn or on YouTube, and we'll address that throughout the conversation. So Mihir, I want to start with talking about how you've spent a lot of your career modernizing financial systems, from moving from like monoliths to microservices to containers, and a lot of different architectural changes and modernization in there over the course of your career. So looking back, what would you say has been the hardest part of transforming legacy systems?
This is awesome. I think more than the code and the cloud piece of it, I think it's the primary thing is culture and the sentiment behind something. So you can put up architectures, you can put up diagrams, you can put up like documents around just, hey, here's why it is better, but what is it that you're going to give, incentivizing the people who would benefit from doing it and taking them along the journey. So I think more so than just the technology aspect of it, the cultural and the organizational shift is kind of the major part of the transformation. Going from monoliths to microservices to saying, hey, we can just containerize this, to saying, hey, we can just run it serverless. All of that is like part of the journey. But you need to have a very solid foundation in terms of the why. And you need to motivate the people around you to ensure that they are all aligned to the vision of doing this. And more so than that, I think you have to give them the autonomy to operate within their scope, instead of spoon feeding everything or saying like, hey, here's how you should be doing it, and balancing that with the technology evolution that's happening around us.
Yeah, no, that makes a lot of sense. And it's a common thread, I think, in a lot of the conversations that we have on the Scaling Tech podcast, that the technology changes that we go through obviously carry difficulty with them, the technological change, but often what slows them down or hinders them is more of a human issue, right? Of navigating change within the organization, of getting the team on board with the change, motivating them around it, incentivizing them, as you said. And that's super important, right? Because if they don't understand, what benefit do we get as an organization moving to, a microservice or a more containerized system, then what's the, if they don't understand why we're doing this or what benefit we're going to see both as an organization and as a team, then obviously it's going to be harder to get that change going.
Yeah, absolutely. And I think one thing that I would share is like the takeaway for me doing multiple transformations over the years is you have to start small. You have to ship smaller, prove that it's working, it's safer, it's compliant, it's tied into the controls, and then start scaling it. And again, the scaling tech basically kind of fits into there. The outcomes are always going to be important, but the
Yeah.
journey is equally important to how you got there. I've seen teams, engineers go for the fastest path out to show
Mhm.
progress and to kind of get it done faster. I'm kind of not against it, but I feel like we have to balance that with doing it right. So
Yeah.
future proofing, thinking about like some of the architectural aspects that are non-functional in nature, kind of
Mhm.
helps you kind of bucket it into a solution that would constantly keep evolving. Uh, and one other thing that I kind of keep going back, and this was my early days learning this the hard way, probably, was the architecture is not constant, the solution is not
Right.
constant. You have to keep evolving. Every 6 months, something's going to phase out because
Yeah.
tech has advanced, and that's where like this whole monolithic services to microservices to containers to whatever is all kind of evolving aspects of tech, and
Yeah.
tomorrow there might be something else, right?
Yeah. Tomorrow there almost certainly will be something else, right? And I think it's interesting too, because like even in the way we're kind of framing this question of as if there were three distinct systems, the monolith, the microservice, the container, right? In reality, none of those were static, even at the
Mm.
time that we might have characterized them as being in one of those three phases, right?
Yeah.
And so digital transformation is never ending, right?
Yeah, and I
Technical
think,
architecture evolution is never
yeah,
ending.
that's the part that I'm so passionate about, and I'm sure a lot of viewers would resonate with this. Is the constant learning that this
Yeah.
field provides is a constant reminder of how much there is to learn.
Yeah.
uh, and again, I'm a very small part in the ocean of knowledge there's out there that I've got, but I'm fascinated by so many things that we could learn just doing things differently every single time there's a problem that's posed to us.
Yeah, absolutely. So let's talk about another type of evolution that has definitely I know happened in your career, and probably all of us in listening into this podcast too. Is moving between like proprietary systems to open source systems, cloud migrations. Um, in particular, in like for the industry you work in, and what lessons have you learned about balancing innovation as you move around architectures like that with compliance and risk management during those transitions from one architecture to another?
Great question. I think that's kind of the core challenge of
Mhm.
software engineering, or as a matter of fact, any institution that wants to kind of um, learn from the benefits that open source provides. Open source is amazing. I have so much respect for people who have selflessly spent nights, hours, days, months building something and sharing it with the globe, right?
Yeah,
Um, with that, I feel like it's customary for all of us to kind of contribute to open source, and like just the whole revolution around innovation is all tied into how frequently we get those packages that like, hey, I have this problem, let me go see if someone already solved it. 99% of the time there's someone who's already solved it, or maybe almost 100% of the time they've solved it, but hey, here's this one small thing that I need to do and I'm good. Contribute that small thing back so that others like you would benefit. um, Coming to the innovation, like balancing the innovation with the compliance angle, I think um, from like we adopt open source tools and we have our own proprietary stuff, and uh,
Mhm.
everything is kind of built on the foundation of making sure that everything's good, everything's safe, secure, right? So to me, treating risk as a customer of your kind of software platform is very important. There's been a lot of evolution in terms of policy as code guardrails. So we have OPA, SALSA, SBOM. Some of these checks and attestations, they help you secure your software. But at the same time, I think not always like people think that we can make the happy path the fastest path, and these guardrails kind of play a major role when you want to transform the system. but then you have the guardrails to protect you from diverting or having anything malicious or vulnerable get in or keep them out, right?
Yeah.
And it's a nuanced thing, to be honest, like when I think about compliance and innovation, because I did a panel where it was, hey, how do you balance standardization with developer flexibility? And this is kind of little bit tying into that, where the principle is kind of simple. Controls run continuously in the background, and the evidence is captured, things are happening, and then as soon as they find something, they report back. And then that reporting loop could have the developer in the mix, which says like, hey, here's what's going on, here's what you need to go fix. And you just treat them as a companion rather than like, hey, I have to go do this check the box thing just because they kind of nag me. Instead, make it such that the experience is baked in and the developers kind of benefit from it. uh, DevSecOps has a lot of advancement in that space, where you can have like, things run in the pipeline, do some sort of a shift left checking. That way the developer feedback loop is faster, and like, just productionize compliance. The automation of everything else will happen, and then the developer would not be as bogged down by, hey, I can't innovate because so and so things.
Right. So building in that some of those the dev security ops into the pipeline, I guess is that's an example of how you balance the innovation with compliance by building that directly into the processes and policy as code. You mentioned also.
Yeah. I think the policy as code is very powerful, because uh, again, a lot of open source tools, a lot of proprietary tools are available to do that. uh, Having something that runs centrally as a platform or as a managed kind of interface helps reduce that burden on the developers. So this is where, like, standardization helps. So you have something that is standard, that runs all the time, that's central to the whole enterprise. And then it's kind of tied into this experience piece, where, hey, there's this some system that's always on, keeps a watch and notifies you when you need to take action. And that system is kind of also contributable. So let's say I have something that I want to do something different for me, I should be able to kind of go put some policy in there that basically helps me kind of do other things that might not be. And then maybe that policy has a wider scope, and then it becomes kind of a generalized policy across the company. So
Yeah, that makes sense. So I know that automation and resiliency have been big focuses for you in your career, and especially early on. How has automation evolved that and teams you've worked in, Capital One or elsewhere, from reducing migration times to the modern continuous deployment strategies and pipelines?
yeah, it's a significant it's been a significant evolution as such. Like this kind of takes me back to the time where cloud was still like probably not there, or there was like concept of like semi-private cloud, and public cloud was just about to come on the horizon. The automation focus was on consistency and reducing like the toil for the developers, especially for things like provisioning infrastructure, ensuring that the things are set up right, the firewalls, and like patching of the host. Like these are like all like, I'm probably going way back, like 15 years back, maybe early in my career, I saw all of that. And um, as we see that, right, like these were individual people doing that as a platform engineering team on behalf of the user, on behalf of the developers. They don't have any knowledge of like, hey, where is this software going to run? It's like, hey, here's something that you have, you just give whatever, like check your code into GitHub, ClearCase, whatever, source code repository. And then from there was this team that picks it up and kind of does the platform engineering the old way, where it was all humans and all people doing it. As we matured, the focus kind of shifted from developer kind of velocity and reliability, because everything was taken care of, to, hey, how do we build robust end-to-end kind of continuous deployment, where the developer can push every commit to production as such. And that's basic. Today, the automation is about the entire developer lifecycle. It starts with writing code to ensuring that the code is well written, it's well managed, it's secure, it's safe, and then checking like the quality of the code. So testing the scans that we run on it, like composition scan or static scans that run on the software, ensures that the code is going to be performant, it's going to have all the right things, and then as soon as everything, all the gates are passed, it's gone. It's like really ready to go. And a lot of times you have human in the loop where you still want someone to finally say yes, it's good to go, or you can say like, hey, this is how continuous deployment happens, where I put this commit in, all the things happen in the background through the pipeline experience, and then it's gone. Like once I've gotten the reviews done and it's merged into the branch, it's good to go, right? So I think that's the ultimate holy grail of uh, true developer productivity experience, where the developers don't need to know anything about the underlying system, and true platform engineering kind of plays into that aspect. But I feel like that's very achievable. That's something that we should aspire to do, and with all the guardrails, with everything that we've seen evolve, it's very realistic to do that. I think we need to celebrate the productionization of automation with guardrails and with kind of monitoring observability on top of it, which gives you the freedom to say, hey, I'm confident to push this, and if something goes wrong, it's going to auto roll back. And that's a big factor of the continuous deployment aspect as well, where how do you tie in your SLOs and SLIs and monitoring into your workflow? That way, when you actually release something, you are confident that if something goes wrong, it's automatically going to roll back without impacting a huge level, like a huge set of customers.
Yeah, absolutely. Well, you're using some really important terminology there that I want to highlight. The importance of confidence in continuous deployment pipeline, right? But still having guardrails in there, but making sure that I think you also like reducing developer toil, the toil for developers, right? So excuse me, sometimes there's a tension, right, between the guardrails and the developer experience, or what developers want to be able to do. And so I want to, ask you a little bit about developer experience, because I know you've worked in organizations with thousands of developers, and so that scale has to create unique challenges, right? Because a lot of times when we think about continuous deployment and you go read a blog post about it, it tends to talk about it in kind of a smaller team level, right? But in larger organizations, what does developer experience mean to you, and how do you keep productivity high, reduce developer toil, but all of that without sacrificing governance and oversight?
Yeah, this is one of my passion areas, so I can talk about this all day long. Like especially at larger organizations, I think the developer experience is kind of key to the advancement of that organization as well. Like I kind of think of developers as the core asset of the company that kind of helps innovate, bring things faster, evolve the system, so on and so forth. But what developer experience truly means to me is, how do I help reduce the cognitive load on the developers? How can I keep them or like maximize the flow state where they can heads down focus on doing the things that they should be doing or they want to do, rather than being worried about like, hey, what happened to this thing and what happened to that thing? Oh, I have to go look at these 5 things in order for me to kind of be aware, right?
Right.
One thing I've seen is like developers love to solve problems. So there are different personas of developers.
Mhm.
Developers, like to me, from a broader organizational standpoint, could be bucketed into like the developers who work on business functions. So they're focused on solving business problems. And then the second part is developers who are focused on platforms, who are
Mhm.
providing the platforms to the company, which are more like horizontal teams. but those developers are also kind of the first class citizens in aspect, right? Like it's not just the developers who solve business problems are the customer here, right? So we want to
Right.
think of advancing the developer experience for both of these categories or classifications, and say like, hey, here's how you do things in a standard format. So let's say if someone wants to go and uh, deploy a container, for example, uh, if we give the choice and the freedom to every developer to say like, yeah, you can go choose whatever you want. Someone will choose Kubernetes, someone will say like, hey, I have this Docker Compose, I want to run on like EC2s, or someone will say like, hey, I just want to use some sort of a managed service like Fargate or ECS or whatever. And that's where it starts to break down the focus. The
Yeah.
complexity starts getting into the developer workflows, where now they are doing 5 different things. This is one of the things that also is that elevating factor to providing the standardization. Because hey guys, if you want to do container deployments, here's how you do it, here's the standard way to do it. Now if this doesn't work for you, yes, you might be in the again, making it up, 5% of the people who doesn't fit into that use case. Go solve it. For the
Right.
95, you have standard paths, which is like, hey, these are your paved paths to doing something. And it could apply to deployments, it could apply to testing, it could apply to literally every aspect of software development lifecycle. Now the platform developers are kind of enablers of that standardization, but how do you improve their experience? um,
Mhm.
Give them the guardrails to use the right tools, use the right kind of avenues to write build automations, and generalize those automations for the enterprise. So it needs a little bit of platform engineering mindset, but with the right composition, they should be able to kind of bring their kind of golden paths plus friction removal into perspective. And then we kind of provide them the lift by giving them the right tools and engineering kind of composition to elevate that practices across the company.
Yeah. Perfect. We've got a couple of live questions coming in, so I'm going to switch over to those. So Mario asks, as someone currently learning DevOps independently through platforms like Code Cloud, what core habits or learning milestones would you recommend focusing on to build a strong foundation? And from your perspective, what qualities stand out in early career DevOps engineers that help them succeed in scaling teams and systems? Great question, Mario. Thank you.
Yeah, this is a great question. Um, I was a junior developer at one point in time, and I can say what I did, and maybe that might be relatable here. Uh, for you need to kind of figure out a learning plan first, and I'm sure like there's so much material out there, it becomes tedious for you to see like, hey, should I do Kubernetes certifications, or should I learn a CI/CD tool, or should I do something with resiliency and SRE and whatnot? So I would say start with basic engineering. Start with your engineering principles of, hey, what does a system comprise of? Maybe there's a little bit of how to build systems in general is something that I started with, where I was part of a project, brand new, fresh out of college grad, and there were like all of these like senior developers who had like wealth of knowledge. They were like several years more experienced than me. And this guy was like, hey, how do you kind of get through this monolith that we had? Now it was kind of a tooling ecosystem, and they were like, hey, not many people survive to kind of go through this, so I want to make sure that you don't get overwhelmed because it's a big system.
Right.
And like I started with just running workflows and testing things out by myself, where I started learning the tools. So that was my hands-on kind of approach to learning. Anything that you want, start hands-on. Like you might not be able to make progress very quickly, but slowly and steadily you will start chipping it further and further, and you'll start making bigger dents into the problem, right? So that was one of the strategies, where you start going hands-on deep into the stuff, and then you start pulling back and figuring out, oh, this workflow does that, this is how I do this is how I do that. And then you start then interfacing with the system. So start writing things on the system, so that you can start like having a little more grounded view of what the tool does. Coming to the foundational piece, right? Like basic engineering, when I say it's more around like, hey, if I am, and a lot of this is imagination, right? If I have to run this app, mobile app, let's hypothetically say it's a mobile app that does something X, something like takes notes, for example. What do I need? Okay, I need those building blocks, but how would I host it? What would I do in order for me to make sure that this doesn't fail, this doesn't break? And that's where your engineering thinking comes in, and you start kind of elevating the practices of, hey, I need to have a microservice, I need to have some sort of a way for storing this database. So what database would be better? So you start thinking about it and you start solving some of those problems. Back when I started, I don't think there was AI, or like Stack Exchange was my AI kind of thing. So I used to go Stack Exchange or Google the stuff, and then learn and then kind of implement. So Mario, I hope that helps. I don't know if I give a long and winded answer, but hopefully that should give you a little bit of perspective of how you start. Don't and one key point: don't get overwhelmed. Start small, and you'll get there.
Perfect. No, I think that's great advice. So thank you, Mario, for the question, and Mihir for the answer there. I'm going to go to a question from Andre, who says, hey, Mihir and Aaron, great discussion so far. I had some quick questions. What skills should current and new DevOps engineers prioritize to stay relevant in the AI area? So a little similar to Mario's questions, but more of an AI twist. Should companies be hiring specialized MLOps AI engineers or upskill existing DevOps teams with those? What's your take on that?
Again, great question. I myself am going through the self-learning that I'm doing myself. I think MLOps is a very interesting subject. If you have the context of DevOps, it becomes slightly easier to do MLOps. At least in my experience, that's what I'm seeing. The fundamentals of AI and how machine learning works, I think that's important. So maybe I would suggest learning more about that, and then kind of applying some of the DevOps principles and knowledge that you've gathered over the years to seeing how you can bake a end-to-end MLOps pipeline. MLOps is slightly different. Totally understand that, because MLOps kind of deals with models and deals with data and data pipelines and some of these other things. But at the core of it, it's still a pipeline. So
Yeah.
I kind of try to break it down into smaller kind of subsegments that have parallels to the DevOps aspects, and then start learning those pieces, and then you can bake that in. So learning AI, I would say start with ML. That basically gives you an intro to AI, and then how you implement AI in DevOps. It could be like, and we can talk about this, like MCP agents, like agentic AI is a big thing that's coming up. How do you kind of have those agents built out that would help your overall DevOps workflow? But then how would that also fit into MLOps, right? So that's how I think about it.
Perfect. Oh, that's great. And I'm going to get back to viewer questions in a moment, but I wanted to go back a little bit to continuous compliance. And so for for listeners not familiar with that term, can you talk a little bit more about what continuous compliance looks like in practice? How do you bake compliance into pipelines instead of treating it like a separate process kind of at the end?
Yeah, definitely. So controls are like, or automated checks in the pipeline. So think of them as like, you have a dependency on image scanning, you have a dependency on some infrastructure as code policy validation, you have some change management attestations that you need to do to ensure that you have the evidence to go to production. And like provenance metadata, you can have SBOM, signed artifacts. All of these things are kind of discrete pieces as such if you look at them individually. But when you try to think of them as a compliance engine, you can have them baked together into the pipeline ecosystem. So you can have them more shifted left towards evidence collection, so they run parallelly to the pipeline. So your pipeline's running, but then they are under the hood asynchronously kind of gathering evidence and ensuring that while I have the release decision to make, I have all of these pieces ready. And then you can have the other aspect of what would be the governance point of this. So you can have a centralized kind of policy engine like OPA, for example, or something else that you can use, which provides an oversight into all of the things that you would want to do underneath the covers, right? So the compliance becomes kind of a build artifact, not necessarily a side of the flow. It's more baked into the workflow itself. So you get the confidence, like we were discussing earlier, of security, safety, and compliance to just move faster towards production.
Perfect. So we can't have a conversation about DevOps this month without, in October 2025, as we're recording this, without talking about the big outage that AWS had last week, I think it was, right? So we have a viewer question from Muhammad Wakas, who asks, in the event of a major cloud provider outage like AWS's recent one, how confident are we in our multi-region or multi-cloud failover capabilities? Can you talk a little bit about best practices around that?
Yeah, fascinating question. I was expecting this, by the way. So, so a couple of things that. One of my bosses recently, we were having a conversation, and she brought up a point of like, hey, have you read this Dr. Cook's kind of excerpt on, I think it's called Systems Will Fail. And I'm kind of paraphrasing. And he goes into, and Dr. Cook's actually a doctor, like a physician who's seen, like, medicine, and his perspective was like, things will fail, and you need to start preparing for what kind of failures would you have, and then work backwards from there to kind of apply those into your software engineering practices. DevSecOps and SRE kind of commingle there, where you have to build resiliency into your software that you're developing. Developers can be kept a little abstract from the underlying complexities and details of how resiliency is baked into the application, but there are aspects of which you would want to share back out, right? And we would think of them as like, hey, is multi-cloud the right answer for me? If this is a super critical ecosystem, I want to be always on. If both the cloud providers are having an issue, you still are going to face some sort of a downtime. Now, that's what has happened recently. But in terms of how you design those systems, is how can you have multi-region resiliency practice in line with multi-cloud? So again, uh, I'm not saying that we shouldn't do some of these things, but at the same time, you also have to see how optimized it is. Is cost a concern? Because a lot of larger organizations might not feel the pinch a whole lot, but smaller companies might feel like, hey, is it truly worth it? Versus there's an active passive kind of aspect to it as well, where you keep it like hot standby approach to software, where like, hey, as soon as something fails in my primary, am I capable enough to move it in like 5 minutes, 10 minutes? What would it take for me to have that ready to go without having the burden of running active? With active setups, there are other concerns and constraints with other types of architectures, like your database replication has to be within milliseconds. Some of these other aspects then start kind of creeping into your application handling, because then you are now writing code in order for you to handle a latency somewhere, or you're writing for consistency, which is all good things. But then you have to have a balance between, like, things will fail. The mindset should be, how do I solve this problem? It could be active, it could be active passive, it could be hot standby, it could be n number of practices there are, but it could be tailored to your need, and you can optimize it for cost after the fact, once you figured out, like, hey, here's my threshold of failure, and I couldn't go beyond this, so this is what I would like to do.
Right. Yeah. No, so very much depends on the use case, how much, because not everything needs 100% uptime. And as you said, since some use cases, it might be okay to have a few minutes of downtime while you move over to the other provider. So great question, Mohammed. Thank you for asking that. And Mario points out too, lest we upset anyone at AWS, they're not the only ones, of course, who have outages. Mario points out yesterday we had an outage on Azure Cloud.
I'm just keeping fingers crossed for GCP to not be the next one, because then it would be like, all three got something. It's
Right.
I
Then you
hope
start to worry.
a lot of sleepless nights for a lot of people. So I don't want to wish that on anyone.
Right. Exactly, for sure. No, great questions. Thank you. And for those watching, you're welcome to continue to ask questions. I want to move on a little ahead in our discussion here, because there's a really interesting blog post that you wrote for the Capital One blog in the past called Intent-Based Engineering. And I want to make sure that we have time to discuss this, because I think it fits into like the future of DevOps and AI. And in that blog post, you imagine a world where developers describe what they want to build and the system handles all the implementation details for us. So can you explain that idea further for us, and how close is current technology to making this a reality?
Yeah. This has been like this was something that I thought of last year, when we were still like, AI has been growing by leaps and bounds. The advancements that we see has happened so fast, and it's amazing the times that we live in, that we are able to experience that.
Yeah.
So I'll start with the concept of what intent-based engineering meant when I first wrote that thing. Um, as a developer, I don't want to know all the gory details of how systems are set up, what I need to be worried about, what I need to think of. And I kind of took a step back and said, like, hey, what if I want to have a use case? I just want to tell a system that, hey, I just want to run like, I need a resilient API that's safe and secure and can handle like 1,000 requests per second. And the system basically takes into consideration what I'm saying and gives me a path to say, hey, you should be doing, uh, just making it up, a Fargate container or some sort of a Kubernetes container or some sort of container that can serve that traffic. You'll need an ALB, you'll need like Route 53, but not share that details with the user, saying, okay, I got it. You should
Right.
write a container. You should write a service that I can deploy as a container. Done. Or it could be like a serverless function or of sort, right? Like, but the developer's job ends where they provide the intent. They get feedback in terms of like, hey, give me more metadata. What does that mean? Like, would you have a database that you need? Would you be like, how critical is this app? Based on some of those user human English inputs, the system kind of identifies and says, hey, I know what I need to do. I need to build this system active. There's going to be this NoSQL database, this service. I'm going to run this in this domain, and I'm going to give an endpoint at the end of it. And then it starts from the intent. The platform kind of does the heavy lifting of, hey, this person, whoever requested this, needs to have a repository that they need to store in their source code repository. So I'm going to create one. I'm going to scaffold it with the right hello world kind of program, and I'm going to give them the config that the pipeline would then pick and then go all the way to production. And to me, that's like, hey, I have a ready to go hello world program that's running. Now hello world could be, you can have a scaffolded input to what their use case was. It could be a framework that the company uses, or it could be some sort of a library that's already existing in the company, and then you are just basically using that to kind of bake that into the initial build out. And the developer comes in and says, okay, now for example, I'm writing an order service. I need to write this business logic of, like, putting orders in the database as they come in. They write that business logic, they commit the code, and things just happen for them. They don't need to know everything that's under the hood. They just have an API endpoint that they can test, for example, if it's an API, and that's it. That's like, to me, transforming an intent to completely black boxed, kind of opaque platform engineering uh, lift, which gives that feedback directly to the user.
Fantastic.
How close are? Sorry, go ahead.
No, go ahead, please. How close are we?
How close are we? I would say with so many LLMs, so much of AI advancement that we've seen, I think we're much closer than what we were when I first envisioned it.
Right.
We have, like, we can have agents today. I've seen some very cool tools available in the market where you can just say, hey, I want to do this, and the agent actually, or the AI actually goes and builds a pipeline template for you, and you just run the pipeline template. Now again, those building blocks are something that you might have also built through AI, and it's just composing that pipeline on demand, on the fly, right? That makes me feel like very bullish on this, that yes, this is very close to being a reality. I'm sure, like, someone's already solved it, maybe. But yes, this kind of environment that we're in with AI as an enabler has certainly put more kind of rocket power behind this initiative, that it might soon be a reality.
Yeah. Well, what I like about the concept uh, is how you could apply this at an enterprise level and in large teams like you work with, right? That the developer can express that intent for what they want to build, but we're not just at least I'm envisioning this is not just using like Claude or whatever of your choice to then create the scaffolding of an application for you, or even in the future to do a full DevOps setup for you, but to do it within the constraints of that enterprise. So to enforce the enterprise architecture as part of that, to enforce that continuous compliance and monitoring are built in, observabilities there right from the start, right? And so that's powerful, and is something that needs to be kind of uniquely solved for each enterprise, for each organization, right?
Yeah, I think the framework is probably the same, but the implementation may differ. So the analogy that I write in the blog is like any tax solution that you go to a website, and like you click, and then at the end the tax gets filed for you. You're not writing 1040s, you're not writing all those 50 forms that you need to submit, right? That's the
Right.
intent. So thinking about it, like when you go through that experience, the platform is checking what security rules you need to have, what firewall rules you need to have, the well-managed aspects of software engineering from both compliance, auditory, regulatory requirements, or from the standpoint of like, hey, is this optimized for cost? All of that is kind of the platform uh, uh, responsibility. The shared responsibility model comes from the developer providing the intent to adhering to the platform constructs. And the platform constructs are, and it's not one platform, it might be 50 platforms in the back end doing all the heavy lifting, orchestrating around all of these pieces. But then developer doesn't need to know. They are like,
Right.
hey, I got this done. It like Cloud Code or like Codex or some of these tools like Windsurf, they are like that in a way, little bit, but they are based on the limited context. In this case, it might be like the enterprises platforms that are hooked into this kind of orchestration engine, which helps provide the lift for the developer.
Yeah. Interesting. So I know you have, as many are, kind of done some exploration around developer productivity in age of AI development tools. How is an intent-based engineering and AI, how is this going to change the DevOps lifecycle? If you reach that full intent-based engineering scenario that we just described, how does the role of the DevOps engineer change in that?
So, great question. I think the DevOps engineer basically would use AI as an enabler for building that platform. The platform's not going to build by itself, with the context of the enterprise, with the context of everything that needs to happen. So to me, the DevOps engineer's role shifts a little bit, where they are kind of the quote unquote architect of the ecosystem. So They can use AI for planning and designing the ecosystem to the best practices. They'll be using AI to ensure that comprehensive testing is happening for the platform constructs, because those platform constructs are now going to impact everyone. And then, like, how do you use like artificial intelligence to provide like observability and like monitoring aspects of the pieces that you've built? uh, to me, human cognition is limited. Like, I can look at a spreadsheet with maybe 5,000 lines and say, yes, this is the pattern that I'm seeing. AI, on the other side, can look at a spreadsheet that's 5 million rows and say, hey, here's what I'm seeing. So
Right.
maybe leveraging some of that to find hotspots, or to find like optimization opportunities, to find like things that fundamentally would improve the platform. I think that's where you need the DevOps engineer to kind of focus on. It's more of a companion to how you build stuff, rather than like it's a catch-all of like, hey, you just tell this thing to do something and it's going to do it. Not really. I mean, not yet. But that's where the operational aspects of the platform are still going to be uh, built on the shoulders of like DevOps engineers. The role might just evolve, but the core functions that the DevOps engineer kind of does is probably going to stay the same, with more enhanced kind of companion with them, like AI.
Yeah, absolutely. Yeah, it is. AI is definitely going to be our companion on this journey, no matter what our job title or our role is, for sure. And so learning how to adapt to that and to use that to best augment our capabilities and take our teams and enterprises forward is definitely the challenge of these times. And so as we're nearing the end of our time together, unfortunately, but really have appreciated the conversation, Mihir, and also those of you watching, great questions you've asked. Thank you. My last question want to ask for engineers working with complex systems, and especially in this world where technology is evolving so fast. What closing advice would you give those engineers about balancing safety, compliance, and innovation as technology continues to evolve?
Um, okay. I think my primary advice would be to treat these three kind of competing priorities as like, instead of treating them as competing priorities, we should start treating them as interconnected pieces of a common goal. You cannot have a sustainable innovation without safety and compliance, obviously. And
Right.
like it's like the three tire like scooter, right? Like,
Right.
one wheel is off, you're not gonna go forward, right? So I would say, when like CI/CD pipelines are kind of automatically doing a bunch of things, they provide you the lift, but are you kind of ensuring that it is not only providing you the lift, but also providing you safety and security? Lift in the sense that the developer is not doing anything manually. It's all automated,
Mhm.
it's fast, it's repeatable. And then on top of that, if you apply the lens of compliance, it's just gonna make it even more bulletproof. Um, when you build a shared like risk taxonomy first, like what we were talking about, the three pieces interviewed into a common goal, making it such that like we have to start small. So my key advice would be, start small, publish your kind of paved paths, or like golden paths, and then run game days that kind of include your risk and other partners who are also your first class citizens as a part of this journey, so that you're not kind of taking them at the end, you're taking them along the journey. And then as things evolve, treat that as like a product. Like, you have to keep evolving. There's new things that will come out, you just keep evolving the system. Speed follows safety when like you have safety through self-service. So that's another aspect for developers and the platform engineers to kind of uh, co uh, co-develop this ecosystem. One is the experience angle, the other is the safety angle.
Yeah, I like it. I like that. No, that's great. I think that co-developing the systems, baking these things in from the start, all key aspects to making sure that you're building systems that are safe and compliant and innovative for taking your enterprise forward. So yeah, thanks a lot, Mihir. Do you have any other closing thoughts that you want to share?
No, this was fantastic. I truly appreciate being here and great questions. I think this was a lot of fun, and really thankful for you to be doing this podcast. So appreciate you.
I really enjoyed it and appreciate you joining me. So thanks again for being here, Mihir, and thanks all of you for joining us today on the Scaling Tech Podcast. Thanks for listening to the Scaling Tech Podcast. In addition to bringing the Scaling Tech Podcast to you, at Agility Feet, we help companies to build tech teams across Latin America that are truly theirs. We can help you scale with confidence, with everything from staff augmentation to establishing your own technical center of excellence through our Build, Operate, Transfer model. We can do that for you in Colombia, Panama, Mexico, or elsewhere in Latin America. So check us out at agilityfeet.com to learn more. And if you haven't already, please subscribe to the Scaling Tech Podcast on YouTube, Apple Podcasts, Spotify, or wherever you're enjoying this episode. We'll continue to bring you insightful conversations about engineering leadership and building technical teams. To see our past episodes, check out scalingtechpod.com.